Hello and good day. Today I'm going to present about our project entitled IoT Smart Plant Kit. Let me start with introduction of IoT. IoT is a network of internet-connected objects and web services for monitoring purposes. The core idea behind IoT is that almost all physical things in the world may be converted into a computer that is connected to the internet. To be more precise, things do not transform into computers. However, they may feature as mini computers or smart objects. So we choose to execute this IoT Smart Plant Kit is because we acknowledge the environmental harm due to intensive farming without supervision, and until now R&D in food crops is still not enough compared to agriculture itself. For this project, our target user is a client who is unfamiliar with planting and farming but intends to do so as a hobby. The problem for the client is the inadequate time and skill to do planting and farming. Therefore, the objectives of this project are to assist the local community in gardening activity, ensure the user are able to monitor the factors affecting plants' health, and to provide a portable, practical and modern device for the user. Next, I will pass the floor to Amirul.
For the methodology of prototype assembly, the overall process can be seen in the flow diagram shown. The project starts with an initial planning to plan the whole journey of the project ahead, which is then followed by problem identification, idea generation, designing prototype, finalizing prototype, engineering analysis, prototype implementation, users outcome survey, and ends with the final report. In the problem identification, we implemented two design thinking tools to obtain the user's insight in order to further understand the problem and start generating idea. The method is a qualitative study through online forms by using Google Forms, and the second method is by referring to related and relevant articles and research papers.
Moving on to the result for this project, after we've done assembling and finalizing our first prototype design, we then again reach out to our target users to get their feedback. So what we have concluded is 90.7% of our target users agree that this IoT Smart Plant Monitoring Kit helps them in maintaining their plants' well-being. And then we also obtain as much as 85.2% of the total target users have claimed that they were able to monitor the parameters of the soil moisture, temperature, light intensity and humidity for their plant. And finally, 87% of the total target users have acknowledged that this kit is practical to be used for their daily use and were able to monitor their plants' well-being.
Lastly, for the project significance, this project is aligned with one of the Sustainable Development Goals, which is the number 11, make cities and human settlement inclusive, safe, resilient and sustainable, where this project aims for sustainable food source by encouraging people to grow food at home. This prototype will be beneficial for those who are having difficulty monitoring their plants and people who have no gardening experience yet are interested. These are possible thanks to the introduction of IoT or the Internet of Things, where the data is being collected and saved in the cloud file to the application, allowing users to remotely monitor their plant. This study might be benefit future research by providing information regarding the optimal condition for different type of plant.
Alright, so over here we have our first design prototype for our IoT Smart Plant Monitoring Kit. So basically, as you can see here, we have two different sizes in which this is our initial plan. We plan it to make it much more smaller, so it will be much more portable. However, since this is our first design prototype, we make it much more bigger so that it will ease our maintenance and assembling process. So if this project were to be improved and developed in the future, we can make it much more compact and much more smaller than this initial plan, so that it will be much more efficient.
So as we can see in this project, we have three main sensors, which is DHT11 temperature and humidity sensor, light sensor, which is, and then soil moisture sensor. So all these three main sensors will be monitoring the plant condition and controlled by a microcontroller, ESP32, not MCU. Then our prototype is powered by a rechargeable battery that can be charged by solar cell through a charger module. And then, as you can see here, is the real-time monitoring reading for a web dashboard. And as you can see, this is the mobile web dashboard. Right. So as you can, this is the temperature reading and humidity reading that will read the surrounding temperature and humidity of the plant. And then here is the light intensity reading and soil moisture reading. So we also have a watering time and fertilized day option that can be prompted from the user using this keypad. So if I press 1, the daily watering will be 7:30 AM, and if I press 4, the fertilizer day will be set Wednesday. Right, so another features on our prototype is the notification. So it will notify the user if there is a problem on the plant condition. For example, if there is no water on the plant, there will be notification on a dry soil, and then if there is no light surrounding the plant, there will be a notification on low light intensity. So as you can see, the reading is going down, and when it reaches below 100, there will be notification on low light intensity. So that's all for our prototype demonstration. Thank you.